Hi, welcome back to the channel. In this video, we're going to continue from where we stopped in the previous video, which is how to evaluate definite integrals and learning some of the rules of integration that allows you to integrate some of those functions with boundaries, okay, to evaluate the solutions at. Now, let's look at the second and the third one. The first one here is this, okay? Integral of this x squared plus 5 dx. Okay, now notice that what this is not a simple function that is being modified, so we need to solve this thing thoroughly. And when you look at this, what did I ask you to find? To check first, check if the derivative, if you can find, if the numerator can be gotten from the derivative of the denominator. Right? This is what you should look at. This would give you an idea of whether you'd have substitution rule to solve the problem or not, okay? Now think about derivative of x squared plus 5 is what? 2x plus 0, right? So it's 2x. Notice that what? Oh, we have x in the numerator, which means we can get this x from this derivative. All we need to do, remember that substitution will still work if you know that it's just a constant that is multiplying this number or this function that will give us the derivative of the denominator, right? So it can be scaled by a factor, by a scalar number, and that would not affect the solution, right? That would not affect you in using this particular substitution method, okay? So there's no problem if you just see the function is being multiplied by a constant, it is quite fine. You can use it. So now you just need to substitute u for the denominator, and then du dx would be 2x, okay? Now you make the x over a formula, which means the x is du over 2, okay? Now all you need to do is just substitute things. X is there. We have not done anything to this. We've done something to the denominator, which is u. And then the x, we have done something to it, which is du over 2. Okay, brilliant. So, oh, sorry, du over 2x. Okay, let me not miss that part. Now that we have this, which means x can now cancel out. So what we have left is 1 over 2u du. Now, integration of this, you can just basically take 1 over 2 out. Remember, it's a constant, you can do that. Now, integration of 1 over u is just what? Ln u, right? Now we are going to evaluate this. Don't forget, this is at x because we haven't, we don't have the boundaries for u. We have the boundaries for x. Now, substitute u back into this solution, which means u is x squared plus 5. So ln x squared plus 5. We now evaluate this at x equal to 3, x equal to minus 3, which is quite easy now. So make sure you put brackets around your solution, right? It will make everything clean and smooth, okay? So we are evaluating first at the higher boundary, which is when x is 3. So that will be 3 squared plus 5 minus 1 over 2 ln minus 3 squared plus 5, okay? Does this make sense? Yeah, I think it does. Okay. Now let's quickly simplify. This is 1 over 2 ln 9 plus 5, that is 14, minus 1 over 2 ln minus 3 squared is also 9 plus 5, that's 14 ln 14. So this will give us 0. Okay. So that will be the solution to that particular problem. Now let's look at the second one. So what is the second problem here? It states 1 to 0. 2x minus 8x squared over 1 plus 4x. Please pay attention to this. Now, if you look at the previous problem, we notice that what the degree of this polynomial is less than the degree of numerator is less than degree of denominator. Now, when this happens, you try substitution rule, okay? Substitution sometimes, most times would solve the problem, okay? But so the times that substitution would not solve, the other alternative is when you observe. So let's categorize it here before we move on. Okay, let's categorize it here. So let's say you have right? Okay. Now, the things that you need to check is if you're dealing with polynomials. So this is when numerator and denominator. So when the numerator and denominator are polynomials. Okay. Okay. So the first thing that you need to check. So the first thing that you need to check is if the degree of the numerator is less than degree of denominator. Now, if this happens, the first thing I should try is what? Substitution. Because as you can see, if I find the derivative of the denominator, that would be one degree less than whatever might be in the numerator, right? I mean, if I find the degree, if I know that the degree of the denominator is higher than the numerator, right? And it's just higher by the degree of the numerator by 1. So let's say numerator is degree 3 and denominator is degree 4, right? This tells you that what you can use substitution, because when you find the derivative of denominator, it's going to be 1 less than the degree of it will be 1 less than this degree 4, right? Which will be degree 3 if I find the derivative. So because the degree is 3, I can use substitution rule so that this numerator will cancel out when I do the substitution. Okay, so this is what you do. When you find out the degree of this is less than this, try substitution, especially if degree of numerator is 1 less. If the degree of the numerator is 1 less than the degree of denominator, okay? So this is what you do. When you figure out what degree of the numerator is 1 less than the degree of the denominator, then you use substitution. Now, another thing is this. If this fails, right? Check if you can factorize the denominator. This part we are going to look at in a future video where we use what we call partial fractions. So check if you can factorize the denominator. If this can be done, then use what? Don't forget, this rule is still under the fact that what? The degree of numerator is less than the degree of denominator. So when this happens, what do you use? You use partial fractions. Okay, so let's move back into the problem. Okay, now we notice that the second rule I wanted to mention before we move back to the problem is, what if the degree of numerator is greater than or equal to the degree of denominator? What happens is, when this happens, first of all, do long division before, use long division, right? Use long division to simplify the problem. Okay, so let's see how we can apply that here. So the second rule, so now when we check this, check that the degree of numerator is what? 2. And the degree of denominator is what? 1. Because the degree of numerator is bigger than the degree of denominator, what do we do? We do long division first to simplify. So, so the first step here is you do the long division. Make sure you rearrange this from the highest degree to the lowest degree. We do the same thing here, from the highest degree to the lowest degree. So we divide this thing first. Now 4x into minus 8x squared, that will be minus 2. Then minus 2 times, minus 2x. So minus 2x times 4x, that's minus 8x squared. Then minus 2 times plus 1. So we use this to multiply everything here. Minus 2x plus 1 times 1, that would give us minus 2x. Then we subtract. Now the first time when you subtract them, you get 0 here. Then 2x minus 2x, that will be plus 4x, okay? Again, we do the division again. 4x into 4x is just 1. So 1 times 4x is 4x. 1 times 1 is 1. So when you subtract this, you're going to get minus 1, right? Minus times plus 1 is minus 1. This part will be 0. Okay, 4x minus 4x is 0. So we're able to divide this. So what do we do with this information? Now notice from elementary maths that we can now write this function here. We can write this function here as what? Product of the so this is called the dividend. And we can multiply by the divisor, which is 4x plus 1, times the quotient, which is minus 2x plus 1, then plus what? Minus the remainder, okay? Minus the remainder, okay? Or another way is, in other words, it's simple as saying minus 8x squared plus 2x over 4x plus 1 should be equal to the quotient minus the remainder, so plus the remainder over the divisor. Now notice that these two are equivalent, which means if I divide both sides by 4x plus 1, 4x plus 1 would come to the denominator here. It will cancel out here, so I'll have minus 2x plus 1, and in here it will come to the denominator again. Okay, so this is true. Now that is what we're going to use to solve this problem. Okay, so what it means is 0 to 1 minus 8x squared plus 2x over 4x plus 1 dx should be the same thing as minus 2x plus 1 minus 1 over 4x plus 1 dx. Okay, now you can now separate them. Let me see if the boundaries are correct. Okay, it's correct. Now you can now separate them, separate the integrals. Or you can just do it all at once. In this case, you could just quickly write your final answer. Now, integration of minus 2x is minus 2x squared over 2. Now, integration of plus 1 is going to be 1 times x. Now, integration of minus 1 over 4x plus 1, just the rule I just taught you today, this is going to be what? Minus integral of this is going to be ln 4x plus 1, then we divide it by what? 4. Okay, we divide it by what? The scalar multiplying x. So if you haven't watched that video yet, the link is in the description. It is part of the playlist for this particular problem solving series. Make sure you watch that video that I have uploaded already before this one. Okay, now that will be ln 4x plus 1 over 4, and we're going to evaluate all of this at x equal to 1, x equal to 0. Okay, so this gives us minus x squared plus x minus ln 4x plus 1 over 4. Now we are evaluating all of this, don't forget, at x equal to 1, x equal to 0. So it's nice to put bracket around this. Okay, now finally, let's evaluate this. At 1, what do we get? At 1, we have minus 1 squared plus 1 minus ln 4 times 1 plus 1 all over 4. Okay, minus 0 squared plus 0 minus ln 4 times 0 plus 1 all over 4. Okay, now evaluate this. This is minus 1 plus 1 minus ln 5 over 4. Evaluate this. This is my 0 plus 0, so it's just minus ln 1 over 4. So what does this give us? The first one will give us minus ln 5 over 4. The second one will give us plus ln 1 over 4. So when you add those two together, what do you have? You have 4 minus ln 5 plus ln 1, which is ln 5. Okay, so we can just say this is ln 1 minus ln 5 over 4, which is just, so use the rule of logarithm that says when you subtract two logarithmic functions, it's just the division of the inside functions, right? So that will be ln 1 over 5 over 4, okay? So this will give you the final answer to the problem. So that is the evaluation of that problem, okay? Right, now there are several ways to evaluate this. This can also be written as ln 5 raised to the power minus 1 over 4, which is minus ln 5 over 4. Okay, you can also leave it in this form. So both of them are correct. Okay, that is the solution to the second problem, right? Just follow the steps just follow the solution step by step. I think you would find the explanation very refreshing to see how everything fits in together. And finally, let's look at the last one, which states that the third one, 1 over 2 theta minus 3 theta square over 1 minus theta theta. So it's exactly the same problem, similar to the previous one. The first thing that you need to do, check that the degree of the numerator is bigger than the degree of denominator. So when that is the case, you do the long division first. Okay, but you have to rearrange the terms so that you move from what the highest power to the lowest power. So minus theta into minus 3 theta square, that would give us 3 theta. So how did I get this? I'm just basically doing this, right? Minus will cancel minus, theta will cancel the square. Now 3 theta times minus theta, that's minus 3 theta square. 3 theta times 1, that is plus 3 theta. Then we subtract. Now the first terms would go away, they will be 0. Then 2 theta minus 3 theta, that's minus theta, right? Okay, again, minus theta goes into minus theta, that will be plus 1. So 1 times minus theta, that will be minus theta. Then 1 times 1, that will be plus 1. Okay, then we subtract again. So you have to become comfortable with long division, okay? Minus theta times minus, that the first one will be 0 because minus theta plus theta is 0. Then we have minus times plus 1, that's minus 1. So this would be your remainder. So again, we use the same technique that we used before, which means that this integral becomes 0 to 1 over 2. The quotient, 3 theta plus 1, then plus the remainder, which is minus 1, all over minus theta plus 1, okay? So we just rewrite this polynomial in this form, okay? Now it is quite easy now to integrate this. So integration of 3 theta will be 3 theta square over 2. This is just integration of what? Polynomial, don't forget. Then integration of 1 is just theta. Now integration of this, so it would be nice to rewrite this one first. So this is minus 1 over 1 minus theta, okay? Okay, so what does that give us? Minus, so let's write it out first so that we don't make any mistake. So we are going to integrate this last part. We've already done, okay, so, all right. Instead of doing this, let's recap. Okay, let's look at this. Now, we can write this last part as minus 1 over 1 minus theta, right? Now, integral of this, think about it, the integral of this is just minus, you can take the minus out, 1 over 1 minus theta, right? Now, integral of this is just going to be ln of 1 minus theta, but we're going to divide this by what? Minus 1. Remember the rule of multiplication, right? We are multiplying, this is a linear function of theta, right? Like ax plus b, right? Where we are adding 1, then multiplying theta by minus 1. So when you do this, you have to now divide your answer by minus 1, right? Because the constant multiplying theta is minus 1. Okay, so when you do this, this would cancel out. So your answer is ln 1 minus theta. So we can just bring it here. This is just ln 1 minus theta. So this is the derivative. This is the integral of this. Okay, so let's just quickly write this. Let's quickly write this in the last. And remember, don't forget that we have to evaluate this as what? 1 over 2, 0. So I need to also write here 1 over 2, 0. Okay. All right, good. Now, at theta equal to 1 over 2, what do we have? We have 3 over 2 times 1 over 2 squared plus 1 over 2 minus ln 1 minus 1 over 2. Then at theta equal to 0, this is 1 over 2 times 0 squared plus 0 minus ln 1 minus 0. Okay. Now, what does this one give us? It gives us, this is 3 over 2 times 1 over 4. That's 3 over 8 plus 1 over 2 minus ln 1 over 2. Okay. This is what we have here. On this other side, we have 0 plus 0, 0. So we have minus ln 1. Okay. So I think it is quite clear now. What we need to do is just need to simplify this expression. So 8 here, this is 3 plus, this is 4, then minus ln 2 raised to the power minus 1 plus ln 1. Okay. Now this gives us 7 over 8 minus, so we can bring the minus 1 here, ln 2 plus ln 1. So this is just 7 over 8 plus ln 2 plus ln 1. Okay. So this is just 7 over 8 plus ln 2 plus ln 1. I think if you know already, this is going to be ln 2 times 1, which is 7 over 8 plus ln 2. So this would be your final answer to the problem. Okay. So I hope you find this videos, this part videos interesting, and I hope they help you in your problem solving and in your preparation for various exams, right? I'll see you guys in the next video.